Hello, welcome to the 2017-2018 Science Recap with Mr. Peppily at Bermudian Springs Middle School, grades 6 and 8. So what I thought I would do this year is try to use some technology and try to use the open broadcaster, which is what we use for our morning news. And so I found a few photos of some of the activities, and I wanted to highlight some of the interesting things the students were involved with this year. I did want to start with a few quotes. So typically we're trying to gear our teaching in science so it's inquiry-based. So there's a little quote right there about inquiry-based education. If you can motivate students getting their hands on, that's where the learning takes place. I mean, it's important to know some trivial things, know facts and figures, but we have a tendency to forget a lot of those things, but we do have a tendency to remember when we are engaged and our hands are on things and we're working in collaborative groups and those types of activities. Here's another quote about curiosity. So a lot of what I've tried to do with the lab activities is to foster curiosity, foster that sense of wonder that a lot of students may have had when they were younger, and they tend to lose as they get older in their later middle school years and then into high school. But I think we really never lose that sense of wonder even as adults. So that sense of wonder is a strong key for motivating students. And again, by doing hands-on activities and inquiry-based activities, we can really foster that sense of wonder. One last quote. We focus on the science process skills. So it's more of a way of thinking. It's not just, again, canned knowledge. Canned knowledge is important, but there's so much more to science and all those processing skills, the measuring, the predicting, all of those inferencing, all of those skills that are lifelong skills that go across all areas of curriculum. So those are the kind of things we try to incorporate into our science throughout the middle school, and hopefully at all levels. Here's a photograph of one of the first group activities. This is both 6th and 8th grade. They were working on learning and refreshing their memory about the scientific method. An experimental group of grass seeds grown under just blue and red light, and the control group under white light, which is full range spectrum. Students did a little research, did some predicting on how they thought the grass would react under those different lighting conditions. So we had obviously dependent, independent variable, control group, experimental group, and it's a great way to start the year and refresh their memory for the 8th graders and introduce the 6th graders to how an experiment, an actual controlled experiment, is set up properly. Here's another clip of students working on rock and mineral identification. One fun activity for the 6th graders, they bring in their own small rocks and minerals. We have a few mechanical rock tumblers. We put them in the rock tumblers and we let them go for a few weeks. And then we dump out the rock tumblers and we see what our results were. We take before pictures, we take after pictures. And it's interesting because different rocks and different minerals do wear down differently. And we use sand as a medium to help polish and grind the stones, but also then what happens is you have an accumulation of clay and other sediments, and so that's kind of interesting because students can get to see how clay is formed, and so it's just basically simulating a natural process with some equipment in our classroom. Here's a clip of some 8th graders using their iPads, using technology. They're doing some time-lapse photography. We're doing chromatography, which is the science that involves color. They're using Skittles and some water, and the color bleeds off, but it stays sort of in little sections, at least for a while, and then it starts to blend. So again, predicting skills. A lot of them find that surprising because they don't expect it to behave the way it first behaves once they put the Skittle in. Also, the little S that's on the Skittle floats up to the top. So we talk about why do you think that happens, because it's probably maybe an oil-based decal or something that's sort of sprayed on with paint, so oil rises in water, so the little S's kind of come loose and float to the top. So it's kind of interesting. And so with the time lapse or slow mo, so the kids are having a lot of fun with that activity. Around late fall, Thanksgiving, Christmas time, we have, for the last few years, we've had Tyler Groff come and visit. Tyler was once a student here at Bermudian. He actually sat in our classroom, so that's a nice full circle kind of connection. He is the outreach coordinator at the Da Vinci Science Center in Allentown, Pennsylvania, near Dornery Park. He brings in all types of equipment and hands-on activities. He's brought in electric circuits and things like that to do with our 8th graders, dry ice, liquid nitrogen. He did full school, grades 5 through 8 assembly last year. This year he just worked with Mrs. Kaiser and myself and did a full day of all types of activities with all of our classes. So that's kind of really great for the students to see one of their own who went to school here, sat in the same chairs that they were sitting in, grow up and go out and become a professional in a science field. He actually has an engineering degree from Lehigh University, so that's really cool. And this next picture is the 8th grade students actually doing some activities with the dry ice. The dry ice doesn't melt and turn into a liquid like normal ice. It goes straight from a solid to a gas. It's called sublimation, and it releases the gas, and that's how those balloons are filling so much with the dry ice. So again, the students had a blast doing that kind of thing. Here is a group of 8th graders. This is a simulated town hall meeting from an activity that I call Key Mangrove. So they basically are all people who live or work on a small island that is a mangrove key, sort of like a place in the Florida Keys. Some of them have the role of being residents of the town, shop owners, vacationers. Some of them are industrial workers, such as oil refinery, or commercial, like a shrimp plant manager or shrimp worker. And so there's all different points of view. So it's a great activity because as we're learning about environmental issues, we have the students have an opinion about things before we have this town hall assembly, and then we do a follow-up afterward, and we see that the opinions do actually change after they hear all the points of view. So we have the microphone and the PA system and all that kind of thing. So it's usually a well enjoyed activity. Here is another group of students doing, I believe this is a polymer lab. They were doing, creating a bouncy ball, inquiry-based. They were given the materials without a specific recipe, so they had to figure out the ratios themselves. And so some students will make large, small, medium-sized bouncy balls, and we talk about we're measuring the height of the bounce, dropping it from a fixed point. And so where we might think, well, a bigger one should bounce higher, or a smaller one will bounce higher. So all those predicting skills, all those inquiry skills, and those process skills, and then we put them to the test to see what actually happens. So there's another activity they really enjoyed doing because it was a lot of freedom to design. It wasn't canned where they had to make, every group had to make everything exactly the same, following the same recipe. Here are some 6th graders. This is the stream in the classroom. In this case, it's actually a stream in the hallway. So the blue paper represents a stream, it's water, and you can see all these little cutouts, and they are all different macroinvertebrates. So it's difficult to do this in a 42-minute class in a real creek, because you'd have to walk down to the creek, and the students would need boots and all that kind of thing. But they really enjoyed doing this. So it's classification and identification of different macroinvertebrates. And these things are indicators of the health of the stream without having to do any chemical tests for a creek. We could tell by sampling the population of life that's there. So there are certain creatures that are very sensitive, so they need clean water. There are certain macroinvertebrates that are sort of in the middle. They can handle a little pollution, but not a lot. And there is a third group that is very tolerant to pollution. So as is this artificial stream was spread down the hallway, the students are working in different parts, and you can actually see one section below me Here's a little tributary. So the samples in different parts of the creek were different. So the students then, once they identified all the macroinvertebrates, they had to crunch the numbers, they created graphs and charts, and then we compared and contrasted, and came to some conclusions of what parts of the stream were maybe more polluted, because we were finding certain things in certain areas of the stream, and certain things were missing from certain things, from certain areas of the stream, like mayflies or stoneflies would be very sensitive and require clean water. So if you weren't finding many of those in one area, but you're finding them in another area, you might say, well, there must be some pollution further downstream because we're not now seeing those sensitive organisms. So that's that activity. Here are some solar-powered, little tiny solar-powered robots. Students, again, these were kits. There's an option to make 14 different styles of robots. Students had some freedom on which ones they wanted to make. Some are a little more difficult to make. There's quite a bit of parts, but they're powered with tiny little solar panels. We had a stretch of kind of cloudy, rainy weather, so what they're using in this photograph is a halogen light, but we found that the halogen light does throw a lot of heat, which is not the best thing for these little solar panels. So sunlight works best, and we did have them on the playground, and they also worked wonderfully. As soon as they go out in the sun, the panel starts producing the flow of electrons, and the cars start moving around. I love this. Here I am on one pair. Yes, what they're actually looking at is a rocket that was launched straight up. These are 8th graders that did an engineering. Each student created their own rocket. They were given a thick drinking straw. It's the kind of straw you get with a smoothie, like at Panera. Am I allowed to say that? Panera. But then they have freedom to design if they're putting wings or fins, or 2 fins, 3 fins, 4 fins, no wings, 2 wings. So lots of body designs. And then we have a competition launching them straight up, as well as at a 45-degree angle for distance across the playground. And you can kind of see, again, we didn't have the best weather, even though this was in May. Kind of had some rainy weather, but we endured. This is, it is a battery wrapped in duct tape, neodymium magnets, and paper clips, and some clay, and some copper wire. And basically it is in motion, it is spinning, that's why it looks blurry, and we created small electromagnetic motors. And so we learned how magnetism creates electricity, and electricity can actually create magnetism, so in our study of physics. Some of the other things I've done throughout the year, I incorporate lots of music. My students, especially in 6th grade, we made rap songs to try to help remember certain things, but I brought the guitar in, we played some other types, styles of music, some sort of country songs. So we have a song about the metric system, that I play on guitar, we have songs about the planets. The students created their own rap songs for the metric. We kind of have a rap competition, and some of the students really enjoyed doing that kind of thing, and that is a type of thing students remember doing. And pretty much my last slide. This is if you're a science person, you know this person. I got to see him. This is Neil deGrasse Tyson. I got to see him in Hershey. And this quote, it might not sit well with some people. Maybe some parents wouldn't appreciate this quote, but I understand grades are important. But in the big scheme of things, especially with science, especially with our standards, it's important to learn, but I think our focus should not be on the grades and all the trivial knowledge. Our focus should really be on learning and the curiosity and the inquiry and the application of those process skills across the whole idea of STEM and STEAM. You're using those skills and applying what you learn in math class to my class, applying what you learn in my class to social studies class, applying what we learn in an art class to science class. It all fits together. If you can broaden the way you look at things, your scope, and think a little bit outside the box, we see that it's a lot more than just worrying about your grades and your GPA. That's important in high school, especially your last year if you want to go to a very specific college, a very competitive college. But at the 6th grade, 7th grade, 8th grade level, I say this with reservations, but it's a lot more than just your grades. It's about learning, excitement, and increasing that interest in school, in learning, creating the love of learning, and making students realize that they need to write across all subject areas. They need to be able to read across all subject areas. Everything, it links together. Everything is intertwined, and that's sort of how we approach it. Um, Hopefully across all of our academic areas at school, but I know that's how we approach it in our areas of science in the middle school. So that wraps up the 2017-2018 grade 6 and grade 8 end of the year science report with Mr. Pepley. Thank you for watching this entire thing. I did this with one take, so hopefully it satisfies. Thank you.